Imagine a world where machines can understand us, learn from us, and even solve problems for us. This is the promise of artificial intelligence, or AI. AI is already changing our lives in countless ways, from the recommendations we see online to the cars we drive. And as AI continues to develop, it has the potential to revolutionize nearly every aspect of human existence. In this journey through the history of AI, we will explore the key milestones and breakthroughs that have brought us to this point. We'll meet the brilliant minds who dared to imagine machines that could think, and we will delve into the technical innovations that have made AI a reality. This is the story of how humans are creating machines that can learn, reason, and interact with the world in ways that were once considered the exclusive domain of human intelligence. It's a story of innovation, perseverance, and the relentless pursuit of knowledge. Our adventure begins with a man named Alan Turing, a visionary mathematician who laid the foundation for both computer science and the field of artificial intelligence. Alan Turing was a British mathematician and codebreaker who is considered one of the most important figures of the 20th century. His work has had a lasting impact on the fields of computer science and artificial intelligence. During World War II, Turing played a pivotal role in breaking the Enigma code used by the German military, a feat that is credited with shortening the war and saving countless lives. His work at Bletchley Park, the British code-breaking centre, was crucial to the Allied war effort. But Turing's contributions extended far beyond wartime code-breaking. He was a visionary who saw the potential of machines to perform complex tasks. In 1936, he published a landmark paper that introduced the concept of a universal machine, later known as the Turing machine. This theoretical device was capable of simulating any algorithm or computation, a concept that laid the foundation for modern computing. This theoretical device could simulate any possible algorithm or computation, laying the groundwork for the development of modern computers. Turing's ideas were ahead of their time and have influenced generations of computer scientists. Turing also turned his attention to the question of whether machines could think. He was fascinated by the potential of artificial intelligence. In his 1950 paper, Computing Machinery and Intelligence, he proposed the now famous Turing test. This test was designed to determine if a machine could exhibit intelligent behavior equivalent to or indistinguishable from that of a human. This test, still debated today, suggests that a machine can be considered intelligent if it can carry on a conversation that is indistinguishable from a conversation with a human being. The Turing test remains a fundamental concept in the study of artificial intelligence. Turing's ideas were revolutionary for his time. He was not afraid to challenge the status quo and think outside the box. He dared to imagine a future where machines could think and learn. A future where artificial intelligence was not just a possibility, but a reality waiting to be explored. His vision has inspired countless researchers and continues to shape the field of AI today. A future where artificial intelligence was not just a possibility, but a reality waiting to be explored. Turing's legacy lives on in the technology we use every day and in the ongoing quest to create intelligent machines. The formal study of artificial intelligence as a distinct field can be traced back to a pivotal event in the summer of 1956, the Dartmouth Workshop. Organised by John McCarthy, Marvin Minsky, Claude Shannon and Nathaniel Rochester, this conference brought together leading researchers from various disciplines to explore the potential of thinking machines. The Dartmouth Workshop was groundbreaking in its ambition. The attendees, confident in the power of nascent computing technology, set out to explore the possibility of creating machines that could simulate human intelligence in all its forms. They tackled topics like language understanding, problem-solving and learning, laying the groundwork for decades of AI research to come. The term artificial intelligence itself was coined by John McCarthy at the Dartmouth Workshop. It marked the beginning of a new era, one where the dream of creating thinking machines transitioned from the realm of science fiction to a serious scientific endeavour. The period following the Dartmouth workshop was a time of great excitement and optimism in the field of AI. Researchers were buzzing with ideas, and the possibilities seemed endless. The workshop had laid the groundwork for what many believed would be a rapid advancement in artificial intelligence. Researchers made significant progress in developing programs that could perform a variety of tasks that were once thought to require human intelligence. These early pioneers were not just theorizing, they were building and testing real systems that could play chess, solve mathematical problems, and even understand simple language commands. One early success story was the development of the General Problem Solver, or GPS, by Alan Turing and Herbert Simon. This groundbreaking program was one of the first to demonstrate that machines could be programmed to solve problems in a way that mimicked human thought processes. This program, created in the late 1950s, was designed to solve a wide range of problems by breaking them down into smaller, more manageable steps. It was a revolutionary approach that showed how complex tasks could be tackled systematically by a machine. While not truly general in its capabilities, GPS demonstrated the potential of AI to tackle complex problems in a systematic way. It was a significant step forward, showing that machines could be more than just calculators. They could be problem solvers. Another milestone was the creation of ELIZA, a chatbot developed by Joseph Weizenbaum in the mid-1960s. ELIZA was one of the first programs to attempt to understand and respond to human language in a meaningful way. ELIZA, designed to simulate a Rogerian psychotherapist, used simple pattern-matching techniques to carry on surprisingly engaging conversations with humans. It was a fascinating glimpse into the potential for machines to interact with humans on a more personal level. Though far from truly understanding the nuances of human language, ELIZA highlighted the potential for AI to interact with humans in a natural and intuitive way. It was a stepping stone that showed how machines could be designed to understand and respond to human emotions and queries. These early successes fueled a wave of investment and enthusiasm for AI research. The achievements of GPS and ELIZA were celebrated as major milestones, and they inspired a new generation of researchers to push the boundaries of what was possible. Governments and private companies poured resources into the field, eager to be part of what seemed like the next technological revolution. Funding for AI research skyrocketed, and new labs and research centers were established around the world. It felt as though the creation of truly intelligent machines was just around the corner. The optimism of the era was palpable, and many believed that the dream of creating machines that could think and learn like humans was within reach. Despite the early optimism, the path towards artificial intelligence proved to be far more challenging than initially anticipated. The initial excitement was soon met with a series of obstacles that tested the resilience and creativity of researchers in the field. By the mid-1970s, the field of AI faced growing criticism and a decline in funding, a period now known as the AI winter. This era was marked by a significant reduction in both public and private investment, leading to a slowdown in research and development. One major challenge was the limitations of computing power available at the time. The hardware simply couldn't keep up with the ambitious algorithms that researchers were developing. AI algorithms, particularly those based on neural networks, required vast amounts of data and computational resources that simply did not exist. The technology of the era was not advanced enough to support the complex computations needed for significant breakthroughs. This bottleneck severely hampered progress in key areas like machine learning and natural language processing. Researchers found themselves constantly battling against the constraints of their hardware, which limited the scope and scale of their experiments. Another factor was the over-promising of early AI researchers. They made bold claims about the potential of AI, often suggesting that human-level intelligence was just around the corner. While programs like GPS and ELIZA were impressive for their time, they fell far short of the grand visions of human-level intelligence that had captured the public imagination. These early successes were not enough to sustain the high expectations that had been set. This gap between expectation and reality led to disillusionment among funding agencies and the public alike. The initial excitement gave way to skepticism and a reluctance to invest further in AI research. The AI winter was a difficult time for the field, but it also served as a period of introspection and re-evaluation. Researchers took this time to reflect on their approaches and to identify the fundamental issues that needed to be addressed. Researchers began to focus on developing more robust and scalable AI techniques, while also tempering their expectations about what AI could realistically achieve in the near term. This shift in perspective laid the groundwork for the more measured and sustainable progress that would come in the following decades. In the 1980s, the field of AI experienced a resurgence of interest thanks to the development of new algorithms and the increasing availability of computational power. This period marked a renewed focus on neural networks, a powerful approach to AI inspired by the structure of the human brain. Neural networks consist of interconnected nodes or artificial neurons that process and transmit information. By adjusting the strength of the connections between these neurons, neural networks can be trained to recognize patterns, make predictions, and even generate creative outputs. One key breakthrough during this period was the development of the backpropagation algorithm. This algorithm provided an efficient way to train multi-layered neural networks, allowing for the development of more complex and powerful AI systems. As computing power continued to advance, neural networks began to achieve impressive results in areas like image recognition, speech synthesis, and machine translation. This progress reignited enthusiasm for AI and paved the way for the transformative breakthroughs of the 21st